Welcome to the fifth video of the series. In our last lesson, we successfully built the connection between Python and Google Earth Engine on our local machine. Now that the connection is ready, we are going to build the backend API for the WebGIS system. We will explore the use of the Flask backend framework, how it handles satellite data, and serve those results to the web interface. A typical WebGIS consists of multiple layers. The user interacts with the application through a web browser. The front-end interface built using HTML and JavaScript sends requests to the backend API. The backend then communicates with Google Earth Engine to process satellite imagery and returns the results to the front-end for display. Let's understand how an API works. An API or application programming interface allows different software components to communicate with each other. In a WebGIS application, the front end sends requests to the backend API. For example, the front end may request satellite statistics for a specific date range. The backend receives this request, processes the satellite imagery using Google Earth Engine, calculates vegetation indices such as NDVI, and returns the results in JSON format. So the backend system uses several technologies. Python is used for programming the API. Flask is a lightweight web framework that handles HTTP requests. The Google Earth Engine API provides access to satellite imagery and performs geospatial processing. The results are sent back to the front end using JSON format over HTTP, which enables communication between the web interface and the backend system. There are several frameworks available for building backend systems. Django is a full-stack Python framework designed for building complete web application for large enterprise portals. Fast API is a modern high-performance framework for APIs. Streamlit is excellent for building quick data dashboards. It is the easiest to use and relies on a Python plugin based system. So in this we chose Flask for following reasons. It's lightweight Python framework and it is simple, flexible and requires very little setup compared to other large frameworks. For geospatial workflows using Python and Earth Engine, Flask provides a very efficient way to expose processing functions as APIs. The project structure for the backend remains the same: app.py, config.py and requirements.txt. We will use two files, config.py for setup and parameters and app.py for the API server and satellite processing. For the backend API, we first need to make sure that Google Earth Engine is initialized properly. In the last video, we created a function called initializeEE that connects our local Python environment to Google Earth Engine using our credentials. If you haven't watched, you can click on the video link above. Then we call initializeEE function. So Earth Engine is initialized at server startup. Next, we define the region of interest. This represents the geographic area where we want to analyze satellite imagery. The scale parameter defines the spatial resolution of the analysis. A scale of 30 meters means that each pixel represents a 30 meter by 30 meter area on the ground, which matches the resolution of Landsat satellite imagery. Finally, the max pixels defines the maximum pixels Earth Engine can process. This helps prevent errors when analyzing large areas or long time periods. This section is called Global Project Constants because these values are used across the entire backend project. We define them once in config.py so they can be reused in different processing functions. Let's go through the app.py file. We import required libraries. We import Flask, JSONify function to send responses in JSON format. The request object is used to receive parameters sent by the front end such as start and end dates. We also import Earth Engine library. Finally, we import config.py to initialize Earth Engine function, area of interest, processing scale and the maximum pixel limit. We create Flask application using app is equal to Flask name. It acts as the backend server and handles requests from the front end. Then we test this route to confirm that the backend server is running. Then we define a function def get Landsat to retrieve and process Landsat satellite data. It filters the image collection based on the region of interest, date range, and cloud cover less than 20%, ensuring clear satellite images for analysis. Landsat surface reflectance values is then scaled to proper reflectance units. Def scale function selects the optical bands and applies the scaling factor. The scaled bands are then added back to the image. Now we define the main API endpoint which calculates NDVI for a given time period. This line creates an API endpoint called /getStats. When the front end sends a request to this URL, this function will be executed. Let's define function def getStats to process satellite data, calculate NDVI, and return the result. Using this, we read the start and end dates sent from the front end. These values come from the URL query parameters which are added after the question mark in the URL. So as you can see in the example, we are sending a start date and an end date to tell the backend which time period to analyze. With this line, we can check whether both dates are provided. If they are missing, the API returns an error message with HTTP status 400. Now this is the main processing step. We load Landsat images, create a median composite, apply scaling and clip it to the region of interest. Then we calculate NDVI using near infrared and red bands, which helps us assess vegetation health. Next, we compute the average NDVI over the region using the defined scale and pixel limits. Earth Engine processes this in the cloud and GetInfo retrieves the results into Python. Finally, we return the result as a JSON response which the front end can use for visualization. Finally, the if name equals main block starts a server in the development mode, ensuring the web server only launches when you run this specific line directly. Now, let's test it. In the terminal, type python app.py and hit enter. Earth Engine will check your credentials and if you are logged in, it connects immediately. Once the handshake is successful, you will see the connection time displayed in your terminal. Now open your browser and go to localhost 5000. If you see the message WebGIS Backend API running, the local machine is connected to Earth Engine, and then type this URL localhost 5000 getStats start and end date. You should see the start and end date, NDVI mean value for a region in the JSON format. That's it. We have successfully built the backend application. In the next video, we will learn about front-end interface. Stay tuned. Happy mapping.